Hey guys, in this second video, I'm going to show how we can use Orange to perform machine learning tasks. Specifically, we're going to train models and then use models to make predictions. So we're going to work on the insurance CSV file, which is in Blackboard. So download that file to your computer. Let's use the CSV file import widget. When you click on this widget, you can select a data set from your computer. So I'm going to go to the downloads folder where I have mine, insurance CSV, open. This shows us the file being imported. Click OK. And now we have this CSV file imported. We can take a look at it by going to a data table. If we connect the widget to data table, we can see this particular spreadsheet of the data. We have 1,000 rows. Each row corresponds to an insurance claim, and one of the variables is whether fraud is reported or not in the insurance claim. And what we want to do to ensure we can perform modeling is make sure we have the correct target variable established. So I'm going to go to select columns in the transform set, and let's connect the file import to select columns. Here, I already have fraud reported as the target. This may not be the case for you. You may have a situation like this where you have nothing for fraud for the target, in which case you want to identify where fraud reported is, move it to the menu here, then move it to target. So fraud reported should be the target. And the unnamed variable, I'm going to move to ignore because that's not an important variable for making our predictions. Now that fraud reported is a target, we now can begin to develop some models. So now if we connect select columns to the data table, we can see how the values are color coded based on the value of the target. Okay. So the first thing that we want to do in order to build a machine learning model is we have to set a means for training a model. So we're going to go to the data sampler here. And what we're going to do is we're going to specify that. And make sure you go from select columns to data sampler, because select columns is where we specify that the fraud reported is a target variable. In data sampler, 80% of the data is going to be used for training, 20% for testing. Click sample data. Okay, so we've now split the data set into a training set and a testing set. 80% in training, 20% for testing. And now we can proceed to implement and assess models. So I'm going to bring in two models here. I'm going to bring in support vector machine and decision tree. These are two machine learning algorithms. And let's also bring in the test and score. So the way that this works is we're going to connect the data sampler to test and score, and we want data sample 80% of the sample to go to data, that's for training, and then the remaining data is going to go for testing. So have the 20% of the remaining data go to testing. Okay, and then we connect the learners to test and score. Okay, so this is how this works. And now when we click on test and score, we'll see the performance of each of these models on making predictions for that 20% of the testing data set. When we click test and score here, we can see how the decision tree has a higher CA classification accuracy than support vector machine. So based on that particular metric, the decision tree is performing better. And that means specifically that for the 20% of the data used for testing, the decision tree correctly classified whether fraud was reported or not 84% of the time. The support vector machine correctly classified whether or not fraud was reported 81% of the time. If we connect the test and score to a confusion matrix, we can basically look at the performance. So the confusion matrix allows us to see where the classifications were wrong and where they were correct. So in 140 situations, or for 140 insurance cases, there was no actual fraud reported, and the prediction was that no fraud was reported. And in 22 cases where fraud was reported, the model predicted that fraud was reported. And by the way, this is the performance of SVM. If you click on tree, you'll get the performance for the decision tree. So you have to click on the model to get the confusion matrix of that model. And here we can see across this diagonal, 12 and 26, those are where the misclassifications occurred. So there were 26 times where the actual value was 1, meaning fraud was reported, but the model said fraud was not reported. And then there were 12 cases here where the actual was 0, so there was no fraud reported, but the model predicted that fraud was reported. So again, along this diagonal are the errors, and along this diagonal are the correct classifications. So you can see that 140 plus 22 is 162. So in the 200 insurance cases, the model successfully predicted the correct fraud status in 162 times. So 162 divided by 200 is the percentage that were correctly classified. So confusion matrices are really helpful for evaluating where the correct predictions were made and where the incorrect predictions were made by the model. Another tool you can use for evaluating models is ROC analysis. This is a visual analysis of looking at the sensitivity versus specificity. These are terms that you can take a look at. It relates to the type of misclassification that are correct versus incorrect. And the closer the model is to the boundary, the better performing it is. So you can use this visual approach as well to compare models as well. And the next thing that I want to take a look at is how we can make predictions, using how we can actually see the predictions being made by the model. And to do that, we're going to use the predictions widget. So I'm going to delete these just to get them out the way. And what we can do for the predictions is we're going to bring in the predictions widget. That is in the model section. And what we're going to do is we're going to connect, that's in the evaluate. We're going to connect the data sampler to predictions, the data sampler to a model, and then model to predictions. And we have to fix this. So what we want is, we only want the remaining data, the 20%, we want the testing data going to the prediction. So the remaining data is the testing data, that's the 20%. That's going to go to predictions. And what that basically is saying is that what we're going to do is we're going to have the model, in this case, the support vector machine, which is also called the learner here, they'll make predictions for those, for that 20% of the data. And what we can, because we actually know the actual fraud reported status for that 20%, we can then compare the predicted with the actual. So click OK here. So again, remaining data to data. So that's saying testing data is going to data. And here we want the data sample going to data because we want the 80% being used to train. So this line is basically giving going from data sampler to SVM. That's essentially the training connection. 80% going to train the model, and then lastly, the model is sending the predictions to the widget here. So this is the way that this should be set up. When you click on predictions, you can now see the predictions here. So SVM is predicting that no fraud was reported here. See 0. No fraud was reported. This is the actual. And let's see, in row 3, we do see an error. In row 3, we see how SVM predicted 0, but actually the actual fraud reported was 1. So this is an error here in row 3. But you're seeing the predictions in the first row. You're seeing a measurement of error in the second row, and then the rest of this is the actual spreadsheet, the 20% of testing data. So this is an important feature as well, and we can also do the same with decision tree. We can connect decision tree here and predictors, and now we'll see predictors for the decision tree as well. And you see how we have the SVM, support vector machine predictions, and we also have the decision tree predictions. And then of course you have the actual data here as well. So this is a really powerful way of seeing actual predictions from these machine learning algorithms. All right, guys. In the next video, I'll introduce another data set, and you'll use that for the project.